Okay, awesome. So, good morning, good evening, good afternoon to everyone around the world. Welcome to ACM AI's Beginner Track Workshop series, where we're going to be talking about machine learning. This is workshop number one, where we're going to give you an introduction to machine learning. So, on the slide right now, you should be able to see a link to the slides if you want to follow along. Also, go to the ACM membership portal, and the attendance code for today is incredible. Like we mentioned in the chat, if you are asking a question, do prefix it with at question. It just makes it a little easier for us to find your question. So my name is Sudhanshu. My pronouns are he and him. I'm a second year computer science and mathematics double major. And I'm going to be teaching this workshop along with Jenson and Adithya. Jenson?
Hey everyone, my name is Jenson. I'm a second year computer science major and my pronouns are he and him.
Hello, I'm Adithya Nair and I'm a second year CSE major. And my pronouns are he and him, so yeah.
Awesome. So beginner track. Well, a lot of people are asking, who's it for? Well, we require absolutely no prior experience in machine learning. And we're going to teach you all the coding later in the workshop. So don't worry if you haven't coded a lot in Python before. Beginner track is really geared towards those who want a solid foundation in the fundamentals of ML. And we're going to be doing a lot of cool exercises to really drive home those concepts. We're going to be covering the basics of machine learning and talk about the theory and implementation of models like linear regression, logistic regression, and k-nearest neighbors. We're also going to be talking about some really powerful and commonly used machine learning libraries like NumPy and Pandas. We're going to be meeting right here on the same Zoom link on Tuesday, 7 to 9 p.m. Pacific time. So to talk a little bit about our vision here at ACM AI, we're going to have up next John, who is our president here at ACM AI. John, you want to take over?
Hey everyone, I'm John. I'm president of ACM AI. I just want to thank you guys for all coming out to Beginner Track Workshop. I just wanted to quickly go over what ACM AI does for just like 2 minutes, just in case any of you guys missed it or want to know more about the other things we do. So our mission at ACM AI is to build and develop a community of students who are interested in artificial intelligence at UCLA and beyond. Next slide, please. Our values in our organization are as follows. First, technical proficiency and awareness in artificial intelligence. We, for all of our initiatives, try to either increase your technical ability in building AI models or your awareness of their impacts on society. Second, we aim to create a positive impact on society. And while this is something that might seem self-explanatory and not needed to be said, as you'll learn more later on in AI, in your AI career, you'll find that it's really easy to actually get this wrong and unintentionally create negative impact in society without actually having any malice. And lastly, our third value is diversity and inclusion. We want to make sure that our workshops are accessible to as many people as possible, and we believe everyone deserves an education in AI. Whether or not you're a CS major or an engineering major, whether or not you come from a rich or poor background, AI impacts you and you deserve to have a say in how AI is made. And so these are our three values that guide kind of all of our events. Next slide, please. We have 4 major initiatives that we work on. First is workshops, which is what you're here at the moment. Workshops are basically aimed at teaching machine learning fundamentals to UCLA students. So if that's something you're interested in, you're in the right place. Second is events. If you're interested in our various one-off events, you can come to our events initiatives. These include things such as Demystifying AI and our AI research panel, which will give you kind of an introduction on how you can get into research at UCLA. Third, we have our outreach team, which works on trying to improve AI awareness outside of UCLA. Some examples of how we do this is through a podcast that's focused on diversity and inclusion in AI. And we also have a high school course that we teach to high school students so that they can learn about AI. And lastly, we have our projects initiative, which attempts to actually give you guys a hands-on opportunity to work on AI projects after you've gone through our workshops. So those are the 4 main things that ACM AI works on.
Awesome. Thanks a lot, John. So a lot of you attended GM yesterday, had a lot of questions about the distinction between our various tracks, between beginner track and apply ML, and whether or not you're qualified for advanced. So to talk a bit more about workshops, we have the director of workshops at ACM AI, Vaishnavi. Vaishnavi, do you want to take over?
Hi everyone, my name is Vaishnavi. I'm the workshops director of ACM AI this year. Like Sudhanshu said, if you missed our GM yesterday, I want to quickly go over the 3 different tracks we're offering this quarter and who they're for, what we're going to be covering. So the first track is beginner track. That's what you're at right now. This is open to everyone. No prior machine learning experience is required. So if that's you, welcome. You're in the perfect spot. We'll be going over the basics of machine learning and also implementing linear regression and logistic regression. If you don't know what those terms mean, then again, you're at the perfect spot. We'll be teaching you that throughout this workshop series. After beginner track, we have advanced track that we're also offering this quarter. Advanced goes into more complicated machine learning models. You'll be learning about deep neural networks like CNNs and RNNs. For that track, we do expect that you have some prior machine learning experience and are also comfortable with programming. If you're not sure whether you fit in beginner track or advanced track, show up to our advanced track workshop as well. It's next Monday. The Zoom link will be posted on our Facebook page, and see where you fit in best. And the third track that we're offering this quarter is Apply ML. Harsh will be going over that more in the next slide, but the difference between beginner track and Apply ML is that Apply ML is a lot more implementation heavy. You'll just be working on how to build an ML project from the ground up, whereas beginner focuses a bit more on like the theory side of models as well. I want to emphasize that all these workshops are offered multiple times throughout the year. So if beginner is a perfect track for you now, then please check out advanced track next quarter, and you can even join our projects team after completing advanced. And one more thing, you can attend multiple tracks. So you can attend beginner track on Tuesdays and attend our Apply ML track on Thursdays. Apply ML is also open to beginners. So I'll hand it off to Harsh to talk a bit more about what Apply ML is.
What's up, guys? Thanks to everyone for having me. My name is Harsh Chabisa, and I am the projects director here at ACM AI, and I'm also going to have the opportunity this quarter to teach the Apply ML course along with Varun Shivashankar, who sadly couldn't be here today. So a few things about the Apply ML track. So I think one question that we've gotten a lot is, do I need to have previous experience, or do I need to go through beginner track to qualify for Apply ML? The answer to both of those questions is no. Apply ML is for anyone and everyone, whether you have a decent amount of ML background or you have no ML background at all. So what we found in Apply ML is that our other tracks, beginner track and advanced track, which are both fantastic tracks, by the way, do a very, very good job of teaching the theory and what is going on under the hood of a lot of the different models that we cover, whether that's logistic regression, linear regression, or neural networks. But with Apply ML, we wanted to take the chance to teach everybody how to build an ML project from start to finish. There's a lot more to an ML project than just the model itself. You have to find the data, you have to visualize the data, you have to clean the data. Once your data is ready to go and you implement the model, you have to evaluate the model and then tune hyperparameters. So there's a lot more to machine learning than just the model itself. And those extra parts of ML are what we're really trying to cover in our Apply ML track. Yep, it's right there on the slide. So we're trying to cover things like data visualization, model implementation, model evaluation, all that great stuff. So if this sounds like something you're interested in, please come out to our first meeting. It's going to be this Thursday at 6 o'clock. We're going to drop the Zoom link on the Facebook event soon. So keep an eye out for that. Thanks, guys. Awesome. So John just mentioned that ACM AI has a few different initiatives. And one of those initiatives is projects. And I have the privilege of getting to lead the projects team this year. So what we want to do in projects is give people that don't have a ton of ML experience their first chance to get their hands dirty with a full-on ML project. And that project this year is going to be a daily Bruin view predictor. So what we're trying to do is we're trying to take an article from the Daily Bruin and then predict how many views it's going to get within its first 2 weeks. We feel like this will be really helpful for the Daily Bruin so that they can adequately position articles in order to maximize their readership. So if being part of projects is something that sounds exciting to you, I would encourage you to apply when our applications come out in winter and spring. There is a caveat though. in order to join in order to join projects, we're going to make it a hard requirement that you have to go through our advanced track workshop during fall quarter or winter quarter. So I know all you guys are in beginner track right now, and we're super excited that you're here. But we do require attending advanced track before you apply for projects. So if you're planning on taking beginner track during fall quarter, a great path for you would be to take beginner track during this quarter, take advanced track during winter quarter, and then join the projects team during spring quarter. Of course, if you're already pretty comfortable with the principles we teach in beginner track and you're doing advanced track this quarter, please feel free to apply for the projects team during winter quarter. So as a whole, just a quick summary of everything I said. For projects, we're trying to create a new initiative to give people their first chance at building an ML project from front to back as part of an ML team. If you want to be part of projects, which will be during winter and spring quarter, please make sure you take the advanced track before you apply. Cool. Thank you guys so much. I appreciate you guys giving me a little bit of your time today, and enjoy this awesome beginner track workshop that Sudhanshu, Adithya, and Jenson are about to put on for you guys. Thank you.
All right. Thanks a lot, Harsh. So let's talk a little bit about the kind of topics we're going to be covering at beginner track.
Hey, Sudhanshu, I think you're on mute.
Yeah.
Oops, thanks a lot, guys. So like I said, thanks a lot, Harsh. So right now, let's talk a little bit about the kind of topics beginner track is going to cover. Right now, we're in workshop 1, where we're going to try and give you an introduction to ML. What that basically means is we're going to try and build some intuition about how machine learning is different from traditional programming. Over the next 3 workshops, we're going to be talking about some fundamental algorithms like linear regression, logistic regression, and k-nearest neighbors, which are really commonly used all across data science and machine learning. The last 4 workshops are going to be completely application-based. So we're going to do one workshop where we introduce you guys to Python. So like I mentioned before, if you haven't coded a lot in Python before, really don't worry about it, because we're going to teach you everything you need to know. We're also going to cover data analytics with NumPy and Pandas. And the last 2 workshops in particular are really exciting, because we have a couple of mini projects for you guys where you actually get to build an entire machine learning model from scratch. So those are definitely workshops to look out for, and we really hope to see you guys there. So we know we just threw a lot of terms at you guys, but an important thing is don't worry. Machine learning can be a little daunting when you first get into it. And there is a fair amount of calculus and linear algebra involved. We're going to be talking about some pretty cool and powerful concepts like gradient descent and backpropagation. But like the title says, don't worry. We've got you, and we're going to try and walk you through all of this math, all of these technical details, and try to get you as comfortable with them as possible. So to get started, let's talk a bit about some common applications of AI we've seen in recent times in real life. A really hot topic these days is computer vision. And I'm sure a lot of you have seen the video of Tesla's self-driving car driving around Silicon Valley, identifying cars and pedestrians. So that's a technique, so that's a really cool development in computer vision. And the field has really progressed over the last few years. It's also made a lot of headway in the field of healthcare. And it's in fact helped identify things like tumors and hemorrhages, and has in fact helped save lives and do a lot of social good. Another really cool field these days is natural language processing. So some of you may have heard of this new API called GPT-3 that was recently released. And it's a really, really cool model because it was trained on 175 billion parameters. And it can do everything from create original pieces of poetry to create literature and jokes and articles. So over here, we've linked a post which talks about how this college student used GPT-3 to create a fake blog post. He then posted this fake blog post to Hacker News, and within a day, it reached the top rank in Hacker News without people ever realizing it was fake. So natural language processing is also a really, really exciting field these days. So to get started with beginner track, we're going to be talking about this concept called regression. Now, regression is at the heart of all AI, from everything from your Snapchat filters to the Mars rover. Regression is the building block of all AI. And like I mentioned, it's a really simple, but it's a powerful tool. And that's what makes it so ubiquitous. We're going to be talking about regression in detail in workshop 2. So definitely try and make that workshop because it is a really important concept. So for today, we're going to try and get an intuition on this concept, like I mentioned. And to do that, we have a really fun and innovative activity plan for you guys. So I'm going to hand it over to Adithya now to walk through this game with us.
All right, cool. Hello, guys. So we're gonna take a few moments to kind of give you a really intuitive understanding behind ML. It's a sort of a game slash activity, which will require a little bit of interaction from your side. So can we move on to the next slide, please? Yeah. So this game or activity is called 50-50. So here's how it's gonna go. We are gonna be selecting a particular letter of the alphabet. Our goal is to select a particular alphabet so that at least 50% or 50% of the audience's first names come before this letter and 50% after. It doesn't have to be 50% because some of you guys might end up having the letter we select as the first letter of your name. So all we are looking for is to balance the distribution, I guess you could say, of the audience who has their first letter before this letter we choose and after this letter we choose and on this letter. Sudhanshu, you can just go through all the points so we can so everyone can kind of understand, read it and understand. So here's how it's gonna go. We're gonna start by choosing an arbitrary random letter, and after that, we're gonna show you a poll on the screen that asks you 3 questions. Is the first letter of your name before this current letter we chose, after this current letter we chose, or at this current letter? We will, so once you vote for one of these options, we're gonna kind of look at the poll results, and based on that, we're gonna choose a new letter. We're gonna choose it arbitrarily, of course, but based on the results we get from this poll. And we're gonna do this around maybe 4 or 5 times until hopefully the balance of letters is achieved, so that we kind of get to what you could say, quote unquote, the average letter for most of the participants in this call. So I guess we can get started off. I will share my iPad screen so that everyone can get a little bit of a more visual understanding about this exercise. Um, all right, cool. So as you guys can see here, on the left, we have a column consisting of all the letters in the alphabet. As we said, we will start by choosing a random letter, and then we're going to put out a poll for everyone. Everyone should answer the poll, and once the results come in, we will proceed. So Sudhanshu, you can go ahead and start the poll. Oh, before we do that, the arbitrary letter we're choosing for the start is U. So if the first letter of your name is after U, okay, so I guess the wording is a little bit weird, but if U is well, how do I say this? So if it's above the current, if your first letter, if the first letter of your name is from A to T, select above the current letter. If it's from V to Z, select below the current letter. And if it's at the current letter, just select that. And once all the results come in, we will continue this process. Okay, so I guess as we can see, almost 90% of the people have voted, and it's quite clear that a majority of people have their first letter of their name before you, or I guess in this case above you, based on like the column we're seeing on the left. So that's great. It kind of gives us a little bit of a more intuitive understanding of where we need to select our next point. So try to picturize this. When we began, we didn't know anything. We just randomly chose something of a letter. But based on the results we've gotten as a result of this first poll, we do know intuitively, in some sense, where we should be choosing our next letter. So let's say our next letter is going to be E. So once again, we will do this exercise again. Same question, different letter this time. And so go ahead and answer that. And once the results come in, we will take a look at what they are. Okay, so around 90% have voted. We're getting close to the end. So yeah, again, we can see a few people have E as the first letter of the name. We have a few that have their first letter of the name after E or below E, and some above. And again, this kind of gives us a more like a general understanding of where we should be choosing our next letter. So it's not going to be as big of a jump from U to E, because if you guys remember in the last poll, the percentage of the people who had the first letter of the name above U was around 80%. That was a pretty big jump. But in this case, it's a little bit more balanced. So we're not gonna have that big of a jump. So I guess like, let's say our next letter is gonna be maybe around H. So yeah, we'll do the poll once more. This time the letter is H. So once again, if the first letter of your name is above H, select that option. If it's below, select that. If it's otherwise, select it, it's at the current letter. Wonderful. All right. So it is already pretty interesting where when we chose H, we can see a very quite an even split. We're seeing 41% have their first letter of their name before U, and like 57% after, not U, sorry, H, and 57% of people have it after H. And so we're almost getting there. So we saw like, we went from an 80-20 split to around like a 60-40 split. And now we're approaching that 50-50 balance that we were looking for. So I guess we can try one more iteration. And I guess this time we'll just go a little bit below H, I guess after H, because we already have a very, oh wait, no, sorry, not after H, before H, because we already have a very, very tight split here. So let's take about G for the next one then. We'll do the poll maybe one more time based on what the results of the next poll is, and let's see what we get from it.
Real quick, I think we should make something below H, don't you think? Because the poll was biased downwards.
Yeah, it's like 40-60-ish.
Yeah,
it's 40.
So I think
it's 40% above.
40% above, yeah. So shouldn't we?
So there are more people who are like lower in the alphabet, if that makes sense.
Yep.
Oh right, yeah. My bad, guys. My bad. Yeah, I got mixed up with that. Yeah. So sorry. Since we have more people below H, we need to kind of move and shift our solution in that direction. So we'll take, let's say maybe around J for this, and relaunch the poll and kind of see where we go from there. This is probably going to end up being the last poll because we already had such a tight split in the previous poll. So we will see what our results are here. All right, great. We are kind of honing in, and this is pretty interesting. It's the first time we've tried this sort of activity with a larger crowd. And what we can see here is we have a pretty even split. We have 45% who have 45% of participants who have their first letter of the name above J, or I guess above is before. We have around 42% who have the first letter of their first name after J, and about 30% at J. So this is, it's interesting in the sense that we went from a random arbitrary point that we selected initially, and then we fed our, I guess, model, you could say, or our algorithm. Our algorithm is essentially the poll. We give it some data, and from that data, we get an understanding of how right we are. And we realized from the first poll that we weren't really that right. We were pretty off. So we kind of we kind of went in the direction that would lead us to the right answer based on the data that we've received from like the first round, I guess. And from that, we kind of realized like, oh, we're getting closer, but there's still a little bit more we could do to make our prediction of the average letter of this class a bit better. So we went to H and we got even better. And then we realized, oh, this is great. And we went one more level and we went on to J, and we kind of received an even split there. And I think that's kind of where the like, I guess the average letter of this class. So really quick, just to address one interesting question that we got. The first name that biased towards letters earlier in the alphabet, most probably yes, we would see more people. We would see more people have maybe their first name begin with some of the earlier letters in the alphabet. And it's kind of also what we see with our exercise here, where you would expect in a truly random world that the average letter should be somewhere in the middle. But as you can see, it's a bit biased towards the letters earlier in the alphabet. And that's kind of what we've gotten here. So our predictions have been reaffirmed by this this sort of experiment. So yeah, so Sudhanshu, you can probably take it back. In this way, essentially, we're trying to give you an understanding of, in ML, we don't really explicitly tell what we want we don't explicitly program to get the solution. We just kind of provide the data to a model, and then we kind of like try to push it in the right direction so that we get accurate predictions. So obviously, actual machine learning, not as easy as this. There's a lot of math behind this, but I hope this kind of gives you a little bit more of an intuitive understanding of what we should be expecting when we kind of move into that phase where we kind of test not test, sorry, when we train our model to get to the right answer or the right predictions that we want our model to make. So yeah, so I guess this leads nicely into what exactly is ML, and you can see a pretty interesting little I don't even know what you call it, meme or picture comic. But yeah, it's you can read that. It's pretty similar to that. This sort of Venn diagram gives you like an overall idea of how AI, machine learning, and deep learning kind of relate to one another. So you can see AI is more of a concept, and then machine learning is a type of AI, and deep learning, which we're not going to be covering in beginner track. If you want to get into deep learning, advanced track is where you go. And that's kind of a subsection of machine learning. So if you go to if you can go on to the next slide, we can take a look at a few of the definitions that we have. So artificial intelligence, like I said, it's a concept, and you could think of AI as pretty literal. AI stands for artificial intelligence, and artificial, i.e. non-human, so like basically computers, and intelligence, as in doing intelligent human stuff, which is thinking essentially. So AI at its core is a concept that enables computing devices to do things humans could generally do. That means seeing and recognizing things, making making certain decisions based on making, I guess, at the most rational decisions. Um, and as we keep going, machine learning, which at a very high level, it involves feeding historical data into an algorithm that spits out what it thinks is the right answer we want. And as we saw, it may or may not always be correct, and that's why we have to kind of keep giving it data and kind of retraining our model where so that it eventually ends up matching what our predictions would end up being. So essentially, ML allows for software to become better at predicting outcomes without the need to explicitly tell it how to. That's in a very general sense. All we do is provide data and kind of nudge the algorithm in the right direction so that it becomes better and better at making predictions, just like we saw at um, in the activity that we did. So will definitely see how we do this over this entire workshop series. That's why we have beginner track. We're gonna introduce you to some of the basic machine learning algorithms and models that we use. And yeah, so that's AI and machine learning. A lot of people sometimes get confused and sometimes they use interchangeably. Now you can kind of get a pretty good understanding of what exactly AI is and how it's different from machine learning. So I think as we move on, I'll pass it over to Jenson as he explains a little bit more about the machine learning process.
All right, thank you, Adithya. Oh, wait. Hang on, give me 1 second.
Jensen, I don't think we can hear you. Yep.
Wait, can you guys hear me?
Yep,
oh.
That's good.
Yep.
All right, so data is absolutely essential for any kind of machine learning model, just because like even if you have a really good machine learning model without data to train it, then the model is not going to be of much use because it doesn't have any training under its belt. So in a more general sense, data can be in the form of a text file or a spreadsheet, or it can even be an array of images if you're training an image classifier. So the second stage of the pipeline is the actual training of the model. So when we say like we're training a machine learning model, what's actually going on under the hood is the model is trying to learn a formula that accurately describes the trend of data. So usually the formula is given to the model in advance just to save like a lot of training time, because you don't want your model just trying to guess what kind of formula like it would be right. So for example, like for most simple problem, we'll just use a linear model. So the ML is just trying to learn like the slope and the y-intercept. We'll have different terms for it in the next workshop, but we'll just put it that way for now. We're also going to go into training a little bit more in detail in the next slide. So the last stage of our pipeline is application. So for a machine learning model, that would just mean, like applying your model to like real world data sets. For a data mining algorithm, that could mean interpreting your data and gaining insights from them. All right, let's go into the pipeline in more detail. So the first stage of the pipeline can be subdivided further into input data and pre-processing. So input data can be divided into training and testing data. So note that these two are two different data sets, and we'll get to them again later. So in general, like the more data we have, the better. The second stage is pre-processing. So pre-processing at its core just means formatting your data in such a manner that is compatible with your machine learning model. So you actually do a lot of data cleaning in your pre-processing steps, such as scaling your data and removing outliers. So now we're getting into the part where we actually train our model. That's kind of the exciting part. So like I mentioned, we have to choose a function that can represent our data in that form. And the training data is used to basically develop our model. So machine learning model is gonna iterate through our training data, like usually like multiple times in order to get like to learn an accurate formula. And then after it's done training, it'll move on to the testing data. And this is completely different from the training data. So the model has never seen these testing data, and it'll evaluate its accuracy under these testing data. So just sort of give you a benchmark of how well it's going to do to like a real world data set. And finally, can apply our model to tackle some real world problems. So speaking of that, let's try to tackle what might be a real world machine learning problem. So say you're asked to estimate what a house's price was. So the first question is, what are some possible inputs for a model? All right, I'm gonna launch a poll real quick. Oh wait, this is the wrong poll, sorry. Wait, I can't, okay, for some reason I can't get to the...
Jenson, let me do it, no problem.
Okay, I think it's poll 6.
No, it's a housing poll, I got it, yep.
Oh, it's housing, okay. Sorry about that. Oh wait, let me... Okay, so for first question, like some hints might be, think about what you would need yourself to tell how expensive a house is. And the second question is like, what would the output of our model look like? So specifically, would it be continuous or would it be discrete? We're gonna let this poll run for a little longer. All right, most of you have voted already, so I'm just gonna end poll. All right, so for the first question, most of you guys picked all of the above, which is the correct answer because like obviously the price of a house depends on all these factors. And the second question is, most of you guys picked continuous, and that will be correct because the price of a house can take on any like real value over an interval. All right, so we're gonna take a little break right now. If you guys have any questions, like feel free about like what we just covered, because I know that was pretty dense. You can feel free to ask us, unmute and ask us.
I had a question. Like, I took stats a really long time ago. Can you like reiterate what the difference between discrete and continuous is?
Okay, so yeah, sure. So discrete would be like this or that. So like the output of the function can only take on like certain values over an interval, like say like only integer values. But for continuous, like it can basically take on like any value over some
Got it.
interval. All right, does that
Okay.
answer your question?
Yeah, it does. Thank you.
You're welcome. All right. If you guys don't have any questions, I'm gonna delve more into the intuition of AI.
Can I ask a question?
Yeah, sure.
So in the poll, one of the options was neither discrete nor continuous. So what does that really mean?
That was kind of just a trick question, like trick answer. Yeah, I thought like if there's only two choices, it'll be like too easy.
I want to
Oh.
add,
So I was just like,
sorry, really quick.
go ahead.
I just want to interject and add that you can have variables that are neither discrete nor continuous, which is basically when they can have like an infinite set of possible values that aren't like well defined, but you wouldn't be dealing with that in any of our tracks, so don't worry about it.
All
Thanks.
right. Thank you, Vaishnavi. Okay. All right. Here's a fun activity. Do you remember how you learned to walk? I think most people don't remember, but essentially what happens is you make a lot of mistakes at first, which is normal because no one really gave you the formula for how to walk. So you kind of just have to figure things out yourself. So what ends up happening is you just keep trying like different techniques, and then most likely like you're just gonna fall over again and again. So every time you fell, your brain is gonna realize that you're doing something wrong. Obviously this happened subconsciously because you're still like really young at that point. And eventually after many and many trials and error, you took your first step. Hooray. All right, let's actually look at how Google's DeepMind learned how to walk, because I thought it was pretty interesting. Can you guys see my screen?
Yep. So if you guys are observing the screen right now, you can see it's stumbling a lot in the beginning, but it always eventually more or less learns how to do this stuff.
Yeah, also note that like the hand position is kind of weird because it doesn't really help the AI like walking in any sense. So it's just kind of like moves randomly. All right, cool. So the most impressive thing about like how this AI learned like to walk is the only objective that was given is basically just move from point A to point B. So basically just move as far forward as you possibly can. And this AI learned how to walk, climb, and jump on its own because it figured out those were like the optimal ways to move forward. So how cool is that? Okay, I personally thought it was pretty cool. All right, so a machine learning model learns by trying again, and again. So the machine learning model like predicts the right value by guessing the answer from what like the information that it has. So initially the model has zero information, so all the guesses are suboptimal and like somewhat random, I guess. But as we train it, we can give the model feedback, and if the predictions are bad, then we can just tell it that it's making like bad guesses, and that I should think of the situation a little differently. So after iterating this like many times, the models like start guessing accurately. And this is not due to randomness. There's actually a pretty like well-known algorithm called gradient descent about this, but we're gonna go into that like in our next workshop. So you don't have to worry about that for now. But if you're interested, then by all means, like look it up. So a lot of you guys ask about like, I guess like Python and like stuff about like setting up like which platform to use on your local computer. So we'll actually be using Google Colab notebooks, which is the online service provided by Google, which will come with all the packages pre-installed. Google Colab is particularly good because you can actually like collaborate with people in real time, kind of like a Google Docs. And we're going to be using Google Colab for our guided projects. So, which means you don't have to install anything. But alternatively, if you want to run Python on your local computer, then we'll recommend the Anaconda distribution. But like, just know that it's not required for this workshop series, but it's still a great tool to work with Jupyter notebooks. All right, and that's it for this workshop. Please remember to fill out our feedback form because your feedback is very useful to us. Next week, we're going to cover linear regression, and feel free to follow us on Facebook and GitHub. See you guys next week. If you guys have any questions, feel free to ask us now. We'll be taking questions.
I want to say one more thing before you guys leave. First of all, thank you so much for coming. ACM, all the different committees also have intern applications that we put out every fall. So please be on the lookout for those. It's a great way to get involved with ACM AI or just any of the other committees that ACM has. And last thing, our officers did a great job today. This was the very first workshop they ever presented, but they handled it so well, especially in the virtual setting. So could we just give a round of applause to them? And also to you guys for showing up even in this virtual setting to learn about machine learning. Thank you for coming.
Good job. Thank you.
Thanks a lot, everyone. Like we mentioned, we're going to stick around for another 10, 15 minutes, answer any questions you have. So feel free to unmute yourself or type it out in the chat.
Do we have the attendance code for the workshop?
Yes.
It's Incredibles.
I just put it in the chat, and you can go to the membership portal to do that.
Can we get the link for the feedback form in the chat?
Yep.
Oh, thanks.
Present mode. Okay.
No, I've got it in, Jenson. Thanks.
Okay, cool.
So I'm going to go ahead and